Here's a moment every developer knows. You pull the latest main and it's broken. It doesn't compile, or the types are wrong, or a test you used to pass is red, and none of it was you. Somebody merged something that looked fine, nobody caught it, and now the whole team is stopped while you figure out whose mess this is. So today I'm going to show you how to add typecheck lint tests and a build check to every single pull request using Husky and GitHub Actions, so broken code physically cannot reach your main branch. And this matters more now than it ever has, because you're probably shipping AI generated code, and AI writes code that looks right at a speed you've never worked at before. The old habit of I'll just eyeball it and review doesn't survive that pace. You need the checks to live in the machine, not in your attention. If you appreciate this kind of practical, no fluff engineering content, gently tap the like button. It generally helps more people find it. And let's get into it now. Let me start with the core idea, because everything else is just plumbing hanging off of it. You want 2 checkpoints, not 1. Here's the split. 1 checkpoint runs on your own machine before the code ever leaves it, and it's just to catch the fast, obvious stuff instantly. The other checkpoint runs up in the cloud on every pull request, and its job is to be thorough, to run the things that are too slow or too heavy to run on every commit. The line I want you to remember is this: pre-commit hooks handle what's fast, and CI handles what's thorough. Pre-commit gets typecheck and lint, CI gets the full test suite and the build. If you try to cram everything into 1 checkpoint, you either make your local commit slow that you start skipping the hook, or you push everything to the cloud and get your feedback 10 minutes too late. 2 checkpoints, each doing the job it's actually good at. So let's build checkpoint 1, the local one. This is a pre-commit hook. All a pre-commit hook is a script that runs automatically the moment you try to commit. And if it fails, the commit doesn't happen. That's the whole magic. You don't have to remember to run anything. You type your commit message, hit enter, and the machine quietly checks your work before it lets the commit through. The tool that manages these hooks is called Husky, and it's a standard for a reason. It just works. It lives right inside your project, so the whole team gets the same hooks automatically. You install it, you run its init command once, and it writes itself into your Git setup. From that point on, every person who clones repo gets the exact same checks. Nobody's running a different version of the rules in their head. Now here's what actually goes inside this hook. And this is where the fast part matters. You run your type check and you run your linter, but only on the files that actually change. Let me show you the shape of the command. In npm monorepo, you write something like typecheck the front end and typecheck the back end, and then run lint-staged. And that word, lint-staged, is the secret to keeping this fast. Lint-staged means only lint the files I've staged for this commit, not the entire code base. So instead of your linter chewing through 10,000 files every time you commit, it touches the 3 you actually changed, and that's the difference between a hook that runs in 2 seconds and a hook people rip out of the project because it's too slow. While you're down here in the commit, let's add one more small thing that pays off huge over time. Commitlint. This one checks your commit message, not your code. It enforces a format called conventional commits, where every message starts with a type. Feat for feature, fix for a bug fix, chore, refactor, test docs, and a few others. And then a short description. You cap the header length, say 100 characters, so nobody writes a novel on 1 line, and you leave the casing rules loose so it still feels natural to write. Why bother? Because 6 months from now, when you're staring at 1,000 commits trying to figure out what changed and when, a clean history reads like a changelog instead of a diary of fixed stuff and more changes and please work. You future yourself and everybody you ever hire will feel that difference immediately. And real quick, I want to hear from you on this one. Drop a comment below with the worst commit message you've ever seen in a real code base. Yours, coworkers, doesn't matter. I read everyone, and the funniest ones I'll pin. Okay, back to it. Now here's the part that turns this from a nice to have into something specifically built for the age of AI code. Your linter isn't just for style. You can use it to encode the exact mistakes AI tends to make, so the machine catches them before you ever have to. Let me give you the specific rules I turn on. First, no console, because AI loves to leave debugging print statements scattered through the code, and you do not want those shipped to production. Next, no explicit any. This stops AI from taking a lazy escape hatch and typing everything in any, which quietly throws away all safety TypeScript is supposed to give you. Then, no floating promises, which is a big one. It catches async calls that nobody actually is waiting on. The kind of bug that works 9 times and then silently corrupts something on the 10th. There's no unused vars, which flags the dead code and leftover imports, and AI leaves behind, and no return await, a small cleanliness rule that keeps your async code honest. Each one of these is a specific known failure pattern, and instead of hoping you spot it in review, you write the rule once and the linter catches it forever on every commit and for every person on the team. That's the whole theme of this video. You're moving the discipline out of your head and into the tooling. Alright, that's checkpoint 1. And notice it's all fast. It all runs locally in a couple of seconds. Now let's build checkpoint 2, the thorough one, up in the cloud. This is GitHub Actions, and it runs on the pull request when you open a PR or push new commits to it. GitHub spins up a fresh, clean machine, installs your project, and runs the heavy checks. Your full test suite and a production build. This is the stuff that's too slow to run on every single commit locally, but absolutely has to pass before anything merges. And the reason you want this in the cloud is on a clean machine is subtle but important. Works on my machine is one of the oldest lies in software. Your laptop has caches, weird environment variables, that one dependency you installed globally 2 years ago and forgot about. The CI machine has none of that. It's a clean room. It builds and passes there. It'll build and pass for your teammates too. Now, before I show you the trick that makes this scale a quick word. If you're building an AI-powered business and you're a technical person trying to ship your own thing instead of waiting for permission, this channel is where I break this stuff down every week. Subscribe to Full Stack Data Solutions so you don't miss it. That's the entire reason this channel exists, to help experienced tech people build something of their own before somebody decides you're a line item. So here's the trick, and it's the thing most people miss. If you've got more than one project, and if you're building your own stuff, you do not want to copy and paste the same CI configuration to every single repository, because the day you need to change one thing, now you're editing in 5 places and getting it slightly wrong in 2 of them. Instead, GitHub Actions lets you write reusable workflows. You put the actual CI logic in one public repository, and every other project just points at it and says, run that. With these settings, the working directory, the node version, the package manager version, you pass those as a parameter. I keep mine in a public repo so anyone can use them, and so I only maintain the CI logic in one place. Fix a bug in the workflow once, and every project that points at it gets the fix instantly. That's the difference between infrastructure that scales with you, infrastructure that becomes a second job. There's one last piece, and it's low tech, but it's closes the loop. The pull request template. This is just a markdown file in your repo, and it puts a checklist into the description of every new PR automatically. Did you add tests? Did you run it locally? Does it need any environment changes? The reason a template works when a wiki page doesn't is that it shows up right where the work is happening at the moment you're opening the PR, so it actually gets read instead of ignored. You're not relying on anyone to remember the standard. The standard shows up on its own and asks. So let me pull the whole thing together, because when you stack these layers up, something nice happens. You type a commit, the pre-commit hook type checks and lints your changed file in seconds and cleans up your commit message. You push and open a pull request, GitHub Actions spins up a clean machine and runs your full test suite and build. The PR template reminds you that your reviewer what to check, and the reusable workflow means you set the whole CI half up once and every future project inherits it for free. Add it all up and here's what you actually get. Broken code cannot reach main. Not shouldn't, cannot. The type error gets caught at the commit. The failing test gets caught in CI. The merge button stays gray until everything is green. The best part is you stopped relying on discipline. This system runs without you thinking about it, and that's the point. Your willpower loses to a deadline every single time, so you take the willpower out of the equation and you let the machine hold the line. The whole setup takes about 2 hours to put in place once. 2 hours against every future afternoon you've spent bisecting a broken main branch trying to find out who did it. That's a trade, and it's not close. So if this shifted how you think about shipping code, do me a favor and hit the subscribe. Then drop a comment with the one check you're going to add to your pipeline first. The type check hook, the ESLint rules, or the reusable workflow. I want to see which one you start with. And if you haven't seen it yet, this pairs directly with my video on why you shouldn't write a line of code until your tests are green. That one's about writing the test. This one's about forcing them to run. Watch the next by clicking here. I'll see you in the next one.